Hey everyone, and welcome to today's discussion. We're diving headfirst into a topic that's captivated humankind for ages: time travel. Think H.G. Wells, Back to the Future, the whole shebang. But is it just science fiction, or is there a sliver of scientific possibility hiding in there, ready to explore?
Absolutely. The idea of zipping through time, seeing the past or future is incredibly exciting. But the truth is, it's a really complex issue. Right now, science says it's incredibly difficult, maybe even impossible, mostly because of some pretty mind-bending paradoxes. But let's not get discouraged. There are some fascinating theories to explore.
Okay, so let's start with the basics. I've heard Einstein's theory of relativity has something to do with this. Can you explain that in a way a total newbie like me can understand?
Sure, Einstein's theories, especially special and general relativity, are key. Imagine space-time as a fabric. Special relativity says that time isn't constant, it changes depending on how fast you're moving. The faster you go, the slower time passes for you compared to someone who's standing still. It sounds crazy, but it's been proven.
Whoa, that's already blowing my mind. So if I went super fast in a spaceship, I could travel to the future?
In a way, yes, but it's one-way travel, and I wouldn't jump years ahead. The time difference would be tiny unless you were traveling at a huge fraction of the speed of light, which is currently impossible.
Okay, so future travel is kind of possible, but what about the past? That's the real time travel dream, right?
That's where things get even more interesting and complicated. Einstein's general relativity introduces the idea of wormholes, theoretical tunnels through space-time. Imagine folding a piece of paper in half and poking a hole through both layers. That's a very simplified analogy.
So you could theoretically travel through a wormhole to the past? Theoretically, yes, but there are huge problems. First, we need exotic matter, the stuff with negative mass energy density, to keep the wormhole open. We've never seen anything like that. And even if it existed, keeping a wormhole stable would be a monumental challenge.
So wormholes are a big if. Are there any other theoretical possibilities?
There are a few others, like cosmic strings and incredibly dense theoretical objects from the early universe and rotating black holes. But again, these are all theoretical, and manipulating them for time travel is beyond our current capabilities.
Okay, let's say we could travel to the past. I've heard about the grandfather paradox. What's that all about?
That's a classic. Imagine you go back in time and prevent your grandparents from meeting. If they never met, you wouldn't have been born, so you couldn't have gone back in time in the first place. It's a logical contradiction.
That's a head-scratcher. Are there other paradoxes? Yes, there's the bootstrap paradox, where something seems to have no origin, like a piece of music you bring back from the future and give to a composer who then writes it. And the predestination paradox, where trying to change the past actually causes the very thing you were trying to prevent.
So it sounds like paradoxes are a major roadblock to past time travel. Are there any ways around them?
Some physicists suggest the self-healing timeline idea. The universe somehow prevents paradoxes from happening. Or the branching timelines idea, you create a new timeline when you change the past, leaving your original timeline untouched.
Those are interesting ideas, but they also sound pretty complicated. What about the practical challenges? I mean, even if the physics worked, could we actually do it?
The energy requirements alone would be astronomical. We're talking about bending space-time, which needs more energy than we can even imagine. And we still have that exotic matter problem. Our technology is just not advanced enough.
So it sounds like time travel is a long shot, at least for now, but why do scientists even bother studying it? What's the point?
It's not just a fun thought experiment. Exploring time travel pushes the boundaries of our understanding of physics and space-time. It helps us test the limits of Einstein's theories and forces us to think deeply about the nature of time itself.
So it's about pushing the limits of our knowledge, even if it's a seemingly impossible goal.
Exactly. And even if we never actually travel through time, the questions it raises inspire creativity and innovation in other areas of science and technology.
That's a great point. So to wrap things up, is time travel possible?
Based on what we know now, time travel to the past seems highly unlikely, maybe impossible. Time travel to the future, in the limited sense of time dilation, is real, but not in a way that lets you jump far ahead.
So it's a maybe for the future, but a no for the past for now.
Pretty much. But science is always evolving. Future breakthroughs might change everything.
So for now, it's a captivating dream, a fascinating scientific question.
Exactly. A dream for now, a question for the future.
And that's a great place to leave it. Thanks for joining us on this journey through time.
My pleasure. It was a fun discussion.